I am Anil Kumar. Welcome to my series on functions. I am sharing with you a very interesting example based on transformations. You need to explain and verify with some key points the transformation from the function f of x to g of x, where f of x is 3 square root 2x minus 6 plus 1 and g of x is 2 square root 1 over 2 x plus 1 minus 3. You can always pause the video, answer the question, and then look into my suggestions. So let's begin with the key points on the parent function, right? So the parent function here is square root of x. So let's begin with parent function square root of x. And we'll write down the points and see how they get transformed, or what are the image points for f of x and g of x. So we'll take y equals to square root of x. Now on y equals to square root of x, square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, and 9 is 3, right? So these are sufficient to prove our point. Now the function f of x, which we are talking about, is 2x minus 6 plus 1. Now this particular function, to write the transformed image points, we should actually factor 2, right? So we could write this function f of x as equal to 3 times square root 2 common x. When you factor this out, you get minus 3 here, right? Plus 1. Now if that is your function, then the transformation from x and y will be what? Well, these xy points, the x values will get half, right, because of this 2. So we'll have half of x, and minus 3 means you have to add 3, moving 3 units to the right. Y values will get multiplied by 3, so 3y, and then translated 1 unit up. So those are going to be the coordinate points, correct? So we can apply this and then find our answer. So half of 0 is 0, plus 3 will give you 0.3, the x value. The y value will be 1. So we get this point as 3, 1. When it is 1, then we get 0.5 plus 3 is 3.5, and 3 plus 1 is 4. Half of 4 is 2, 2 plus 3 is 5, and the y value will be 6 plus 1, 7. Half of 9 is 4.5, plus 3 is 7.5. Y value times 3 is 9, plus 1 is 10. Right? So these are your coordinate points on the function f of x, correct? Now let's also see what kind of image do we expect on g of x. G of x is given to us 2 square root of half x plus 1. So you can write the x point as 2 times the x value, original x value, right? And then it is moving left by 1 unit. So that becomes the x point. Y values get multiplied by 2, and then we move 3 units down. So that is for g of x. So any point which is on our parent function will have an image like this on f of x, and we'll now calculate the points on g of x. So multiply this by 2 and then take away 1. So we get here minus 1 times 2 minus 3 will give us minus 3. The second point, 1, 1, will become 2 minus 1 as 1, and 2 minus 3 as 2 minus 3 is minus 1. Then 4. 4 times 2 is 8. 8 minus 1 is 7. And 2 times 2 is 4. 4 minus 3 is 1. 9, 3. So 9 times 2, 18. Take away 1 is 17. 3 times 2, 6. Minus 3 is 3. So those are your points on the function g of x, correct? What I'm trying to say here is, when you are considering transformation from one function to the other, we should actually look into the parent function and then decide. We always get the correct information. Now, it also means that the point 3, 1 gets translated to or transformed to image minus 1, minus 3 if we are talking about fx to g of x. Perfect? Now, let us now consider the mapping between f of x and g of x. So if we begin with the basic parent function square root of x, so from square root of x, you can see that we have mapping to f of x and g of x, right? Let me write down. So from here to f of x, how do we map? We got these coordinates by this mapping, half x plus 3, right? So what really happened here was that the x values were half and then you added 3, right? Okay. As far as the y values are concerned, 3 times y plus 1. On g of x side, let me use a different ink, that will be better. We had 2x minus 1, 2y minus 3 to get the points, correct? So this is your g of x. Now talking about the transformation, as far as the x value is concerned, vertical stretch or compression, we know we have to multiply by 4 to get 2, right? So moving from here to there clearly means that we have to multiply the value by 4, then only you get, right? So 4 times. So it becomes, from here to there, it becomes 4 times the x on the function f, right? And what happens to the translation? Well, the translation part is slightly tricky. What we need to do is we just multiply it by 4, right? So this particular term, if I multiply by 4, which is half x plus 3, I do get 2x plus 12. Now here I get 12, and on the other side I have minus 1. Do you see this minus 1 there? So how are they related? So the translation here is minus 1 minus 12, which is minus 13. Do you see that? So that is how the transformation takes if you are trying to do the transformation from f of x to g of x. Now let's look into the y values. 3y to 2y, you get 2y if you multiply by 2 over 3. The y values of f function, right? As far as x values are concerned, if I multiply this by 2 by 3, what happens? Let's look into this part again. So here we have 3y plus 1. If I multiply this by 2 over 3, I get 2y plus 2 over 3. But here we have minus 3. So that means minus 3 minus 2 over 3. So 3 times 3 is 9. 9 minus 2 is 11. So get minus 11 over 3. So this part should be minus 11 over 3. Is that clear to you? So that is the transformation when you go from f of x to g of x. Correct? So let us check now. So what we will do now is we'll check our values. So we'll check with at least 2 values. So let's consider these 2 values. This and this. So if I am trying to move from f of x to g of x, my value for x should be what? 4 times this, right? So we get 4 times 3 minus 13, and the y value should be 2/3 of 1, right? 2/3 of 1, and then minus 11 over 3, correct? That will be my point. So 12 minus 13, what we get? 12 minus 13 is minus 1, and here 3 is the common denominator. So when you take away 2 from minus 11, you get minus 9 over 3, which indeed is minus 3, or you could write this as minus 1 minus 3. Do you see this? So it matches. And therefore, this particular transformation which we wrote is perfectly fine. You get the idea, right? Now, let us check with another value. So this time, let's take the value 5 and 7, for example. Okay, let's take this value. So what should we get? 5 times 4, so we get 5 times 4 minus 13, and the y value is 7, 2/3 of 7, minus 11 over 11 over 3, right? Okay, so that gives you 5 times 4 is 20, 20 minus 13 is 7, right? So we got this 7. Here we have 14 over 3, 14 minus 11 over 3, right? So which is definitely equal to 7, and 14 minus 3 is 3, so 3 over 3 is 1. Do you see that? So that also matches. So in this particular exercise, you have understood very clearly that to compare the transformations from f of x to g of x, we should go via the parent function, right? So compare, so note, consider parent function. Is that clear? And then you will always get the right answer. And as verified here, it always works, right? Otherwise, getting the translation parts is very difficult. Most of the time you'll get it wrong. Vertical stretch, compression, horizontal, all those things will be fine. However, as far as the translations are concerned, it's kind of complicated. And those values are normally the mistakes for most of the students. If you really want to avoid those mistakes, then this is the real method. I hope it makes sense. Feel free to write your comment, share your views, share this video with your friends. Thanks for your time and all the best.